Good day, everyone. Welcome to the last edition of Scholars University Secondary School online chemistry class. I am Solomon, your online chemistry teacher, and today will be the last class for the term, for the session, and also the last class under sulfur. Now, today we'll be talking about sulfides and tetraoxosulphate salts. Sulfide, the salt of hydrogen sulfide, and tetraoxosulphate salt, which is the salt formed from the replacement of the hydrogen ion of the tetraoxosulphate acid. Now under sulfide, we're going to talk about how we can prepare them, physical properties and chemical properties. Then after that, talk about the uses. Now, sulfide are salts formed when the hydrogen atom in hydrogen sulfide is replaced by a metallic ion. Right? Now, laboratory preparation. Sulfide are prepared using any of the following method. Now, when we are preparing sulfide, metallic sulfide in the lab, and we consider the solubility of sulfide, whether the sulfide we are producing is a soluble one or is an insoluble one. Now, if it's a soluble one, we have a method that we use for preparing it. But if it's an insoluble one, we also have another method. But we have three major methods in which we use to prepare sulfide. We have the neutralization method, the direct combination, and the precipitation method. And the neutralization method is used to prepare soluble sulfide, while uh, the precipitation method is used for preparing insoluble sulfide. But the direct combination method is used to prepare any of the sulfide, whether soluble or insoluble. Now, to the neutralization method. Soluble sulfide are prepared using this method, and the alkali of the metal is made to react with the hydrogen sulfide. Now, for example, this ammonium hydroxide reacting with hydrogen sulfide to form the ammonium sulfide and some water molecule. Also, you can see that this is also sodium reacting with the hydrogen sulfide to give you sodium sulfide and water molecules. And direct combination, I said it is used to prepare any metal, any metallic sulfide. Now, this is zinc reacting with sulfur to, to give you zinc sulfide. Now, direct combination is just combining the constituent of the sulfide. For example, we are producing the zinc sulfide, and that constitute of zinc and sulfur. So we just direct combination of zinc and sulfur. And please take note, in our first class in sulfur, we said that reactive metal like sodium and potassium do not require heating to react directly with sulfur, but they just need to be in their powdered form. Just need to be in their powdered form in order for in order to increase the rate of reaction. They don't need heating. Sodium and potassium, they don't need heating to be to be applied when they want to undergo direct combination to prepare their metallic sulfide. And the precipitation method is used to produce insoluble sulfide. Now, insoluble sulfide like the tin sulfide. The tin sulfide is an insoluble sulfide. Now, please, this is an insoluble sulfide. Now, other insoluble sulfide that we have the mercury sulfide also. Please take note that we can prepare them using the direct combination method or the precipitation method. Please take note, you can't prepare them using the neutralization method. Take note of that. Now, with the exception of potassium, sodium, magnesium, aluminum, and ammonium, all other sulfide are insoluble in water. Please take note. That means potassium, sodium, magnesium, aluminum, and ammonium ion are soluble in water. The sulfide of potassium, sodium, magnesium, aluminum, and ammonium are soluble in water, but the rest are insoluble. That means lead, calcium, zinc, all others are insoluble in water. Now, reaction with oxygen. When most metallic sulfide are heated in air, they produce the corresponding metallic oxide and sulfur 4 oxide. Now, for example, lead sulfide reacting with oxygen. That means when they burn in air, You know, oxygen is the constituent of air that is responsible for combustion. Now, this lead sulfide reacting with atmospheric oxygen to produce the lead oxide and also the sulfur 4 oxide gas. Please take note, this should be gas. This should be in the gaseous form, not in the solid form. Because sulfur 4 oxide is a gas. Please take note of that. This should be G and not an S. Not a S, sorry. And not a S. Now, an exception to this rule is the mercury 2 sulfide. Now, mercury 2 sulfide is the only sulfide which yield the metal itself instead of the oxide of the metal. That means mercury 2 sulfide, when it burns in oxygen or when it burns in air, it produces mercury instead of mercury 2 oxide, instead of the oxide of mercury. Please take note of that. And also, SO2 is also formed. SO2 is also produced. Now, the common product formed between both of them is the SO2 gas. Is the SO2 gas. Please take note. Is the SO2 gas. Now, properties. To coordination of properties. Reaction with dilute acid. Now, most sulfide react with hydrochloric acid. Now, most sulfide react with hydrochloric acid and tetrasulfate acid. This should be tetraoxosulphate acid to yield hydrogen sulfide. Please take note. This is tetraoxosulphate acid. Tetraoxosulphate acid to yield hydrogen sulfide. Sorry, hydrogen sulfide. Now, this reaction is used as a test for sulfide. That means when you are testing for sulfide in the lab, when you have a metallic sulfide, when you have a compound and I'm not sure whether it is a sulfide, when you add dilute acid, whether the hydrochloric acid or the tetrasulfate acid, then if hydrogen sulfide is formed, if the gas produced gives the physical property of hydrogen sulfide from its smell. We said that hydrogen sulfide gives has a rotten the smell is like that of a rotten egg. So if the gas produced is like that of a rotten egg, then you can suspect that the gas produces hydrogen sulfide, and you can suspect that the metallic compound that you have, the metallic salt you have, is a sulfide. Now, this reaction again is used as a test for sulfide in the lab. Now, instead of you talking about the test for sulfide, we've talked about it here, so there's no need for us to discuss it again. Now, to the color of sulfide. Now, the sulfide of lead, copper, iron, silver, mercury, nickel, and cobalt are all black. Now, zinc sulfide is white in color. Tin and cadmium sulfide are yellow in color. They are yellow in color. Now, antimony, which is represented as SB, is reddish, has a reddish orange color. Now, manganese sulfide is pink in color. It's pink in color. Now, please take note when the essence of this color is for us to be able to distinguish which type of sulfide we have. Okay, let's say we have a compound and we know that it's a sulfide, but we don't know the exact sulfide it is. So from the color, you can actually separate. You can actually say that it can be this, and it can never be this. So for example, you have a compound and you are told there is a sulfide and they tell you that it's black in color, and and you are told that it is black in color, you know that it can never be zinc sulfide, it can never be tin and cadmium sulfide, it can never be antimony sulfide, it cannot be a manganese sulfide. It is either a lead sulfide, a copper, iron, silver, mercury, nickel, cobalt sulfide. So then you can now carry out your further test in order to get the cation, which cation is present in the sulfide. That means which metallic ion is present in the sulfide. Now, uses of sulfide. Iron 2 sulfide is used in the preparation of hydrogen sulfide in the lab, and zinc sulfide is used to coat the inside of television screen as it fluoresces or become luminescent on exposed to light. That means zinc sulfide glows when exposed to light. When exposed to light, zinc sulfide glows. Now, tin 4 sulfide is used in paint. Please let's take note of that. Now to tetraoxosulphate 6 salt. Under tetraoxosulphate 6 salt, we're going to talk about their preparation, properties, and also how we can test for them in the lab. Now, tetrasulfate sea salt are normal salts formed when all the hydrogen ions, please take note of the word, when all the hydrogen ions in the tetrasulfate sea acid are replaced by metallic or ammonium ion. Now, most tetrasulfate sea salt are crystalline and they dissolve readily in water, except the following. Now, calcium tetrasulfate sea salt is insoluble in water. Lead 2 tetrasulfate sea salt is insoluble in water. Barium tetrasulfate sea salt is insoluble in water. And mercury 1 tetraoxosulphate sea salt is insoluble in water. But the remaining tetrasulfate sea salts are all soluble in water. Now, how do we prepare tetrasulfate sea salt? Now, we also when we are preparing tetrasulfate sea salt, we consider the solubility of what we are of the type of salt we are preparing, and also the probably you consider also the position of ion in the electrochemical series, because metals below the electrochemical series actually do not liberate hydrogen gas from acid. For example, mercury cannot liberate hydrogen gas from the tetrasulfate salt because it is less reactive than hydrogen. That means, and it is placed below hydrogen in the electrochemical series. Now, the tetrasulfate salts of magnesium and zinc are prepared by the action of dilute tetrasulfate acid on the corresponding metals. They are prepared by the action of dilute tetrasulfate acid on the corresponding metal. Now, please take note that we really don't prepare uh sodium and potassium tetrasulfate salt using this method, because sodium and potassium the reaction of sodium and potassium with tetrasulfate salt with dilute tetrasulfate acid, with dilute tetrasulfate acid is very dangerous. It's very vigorous. It's very, very vigorous, and it's highly exothermic. Now, we can also prepare uh tetrasulfate salt by the action of the tetrasulfate acid on oxide, hydroxide, or triazocarbonate 4 of the metal. And this is the method we use to prepare sodium and potassium tetraoxosulphate salt. Now, we don't use this first method because I said it is very vigorous. The reaction is very vigorous. Now, this method is used in the preparation of potassium, sodium, and calcium tetrasulfate salt. And these tetrasulfate salts are now prepared by the action of dilute acid on the metal because the reaction is very vigorous and dangerous. The reaction is very vigorous and dangerous. And please take note of that also. Now, we can also prepare tetrasulfate salt using double decomposition. And when I mean by double decomposition, we use double decomposition to prepare insoluble salt. Insoluble salt. We use double decomposition to prepare insoluble salt. Now, insoluble tetrasulfate salt can be prepared using this method. So the tetrasulfate salt of lead 2, barium, and calcium are prepared using this method. You can see this lead 2 tetrasulfate salt is prepared using this method. Now, please take note that most tetrasulfate salt decompose on heating, and this is why they are obtained from their solution using crystallization method instead of evaporation method. Now, most tetrasulfate salts decompose on heating, so extracting them or obtaining them from their solution using evaporation method is not an appropriate method. Evaporation is not an appropriate method for obtaining tetrasulfate salt, but rather crystallization method is most preferable for obtaining tetraoxosulphate salt. Now, also we also talked about this when we were discussing triazonitrate 5 salt. We said triazonitrate 5 salt they decompose on heating, so we don't use evaporation to obtain them from their solution, but rather we use crystallization method. Now please take note, we said most tetrasulfate sea salts, most tetraoxosulfate sea salts, tetraoxosulfate sea salts that decompose on heating. Now how do we test for tetrasulfate sea salt? Now when we talk about the test for tetrasulfate sea salt, we are referring to the test for the tetrasulfate 6 ion, the SO42 minus present in the salt. How do we test for it? Some we add some of the unknown solution in a test tube and acidify it with dilute hydrochloric acid. Then add a few drops of barium chloride solution. Add a few drops of barium chloride solution. Now a white precipitate of barium tetrasulfate 6 salt is formed. Now don't forget I said barium tetrasulfate 6 salt is insoluble in water. If the unknown solution contains the tetrasulfate 6 ion, this would precipitate. This precipitate would be insoluble in excess of the acid. That means when we have an unknown compound, when we have an unknown compound and we don't know what it is, okay, you put it in your test tube, then you acidify it using any acid. But please take note, we acidify using the hydrochloric acid in this process. We are acidify using the hydrochloric acid. So when you acidify using the hydrochloric acid, then you now add a few drops of barium chloride. Then if the reaction, if you notice a white precipitate, you can suspect that this is a tetraoxosulfate 6 salt. That it is a tetraoxosulfate 6 salt. So for you to confirm that it is a tetraoxosulfate 6 salt, add the excess dilute acid. That means add the excess dilute hydrochloric acid. Now if the precipitate still remains and does not dissolve upon addition of the excess acid, then you are 100% sure that the salt is a tetraoxosulfate 6 salt and not any other salt. Now I come again. You have an unknown compound. You put it in your test tube, then you acidify using the HCl. Now for you to confirm that is a tetrasulfate 6 or salt, you add barium chloride. Now if a white precipitate is formed, then you can suspect, please take note I said you can suspect that it is a tetrasulfate 6 salt. Now but for you to confirm, you add the excess acid. Now when you add the excess acid and the precipitate still remains, that means the precipitate does not dissolve, then you can conclude that the salt is a tetrasulfate 6 salt, is a tetraoxosulfate 6 salt. Now please take note that if the if the white precipitate dissolve when you add the excess acid, if the white precipitate dissolve when you add the excess acid, then the salt is not a tetraoxosulfate 6 salt, but instead it is a trioxosulfate 4 salt. It is a trioxosulfate 4 salt, and trioxosulfate 4 salt have SO3 2 minus as their ion, as the ion present in the salt. Trioxosulfate 4 salt have SO3 2 minus as the ion present in the salt. Now this is the equation of the reaction. And this is the purpose for we acidifying. And the purpose for we acidifying is to prevent the precipitation of other compounds like barium triazocarbonate 4. Please take note of that. Now we've come to the end of today's class and our lecture for this term. So I want you to like and subscribe to this YouTube channel. And if you have anything for us, or you want to visit us, you want to contact us, you can visit us on our website at www.scholarsuniversalschools.com, or you can call 082 33 94 2989. You can call or send a message. Thank you for watching again this edition of Scholars Universal Secondary School.